All right, so we're back. So what I want to do is, you didn't see that, but that's okay. So basically what we have right here is, hopefully I'll continue. So this was our circuit. We found the voltage drops across there, and then we found using the voltage divider rule. I was going to tell you about the voltage divider rule. Well, I might as well. So let's say we want to find VR1. VR1 is equal to R1 divided into R total. And then we multiply that times it by 12 volts, because that's our voltage total. So if we do all this, so R1 is actually 100 ohms divided into 900, I believe it was 900 ohms. So basically, it's 9,900. And I'm going to put these around here to keep everything. And then what I'm going to do is multiply that by 12 volts. So if I take that ratio 100 to 900, I get 1/9. So if I look at 1/9, and then I times it by 12, 1.33 volts. Like I said, equals to 1.33 volts. So now I continued on power and stuff like that, and you can read the book. But power, remember power from your readings. You'll get into this on sections, chapters 2 and 3, which are very important. Power, I will talk about later, but give you a brief overview of it. Power is the amount of energy dissipated by each one of those resistors. So power is very important. You have too small of a resistor in there, such as maybe you're supposed to have 1 watt and you only have a half watt. Well, you're going to have a nice glowing resistor. So it's not a good idea to forget about power. Power is a key component to any electronics. So anytime you're working with anything that's going to have a heavy load, yeah, you need to really figure that power out. And I'll be talking about it a little later on. The biggest question we have is, okay, I got this circuit. How do I connect this up to a breadboard? So, all right, so here's a breadboard. Pretty straightforward. It looks like a breadboard we use in the classroom. So basically what you have is a top rail going across horizontally in these top rails. The red is your positive, blue is your negative. They're connected all the way across. Sometimes right in here, they're not connected. So again, check, or to put a jumper wire between it. So if you're actually working with that, you can see that there's a positive and there's, let's see, I'm working with here. So basically what you have is you have a positive rail, negative rail. This negative and this positive are not connected up here nor over here. So anything going across here, they give us plenty of power rails here, which is great. So just keep that in mind. So basically what we have right here on our components, this is our battery. So what we're going to do is drag our battery right up here. So what I want to do is I'm going to drag our battery, and I'm going to put our battery right there. And then I want to do is I want to rotate 90 degrees. There we go, positive and negative. Now what I want to do is take and move one of my resistors. So I'm going to put that person right there, and then I'm going to take a next one. You notice I'm doing is I'm putting these in the holes, right? So when you look at these holes going this way, they're connected together, but they're independent going this way. So again, if you see a nice connector right here. The last one is, whoops, forgot it, my resistor. Bring that guy, and there we go. So what I want to do is I want to bring, I'm going to try to bring this guy. I'm going to rotate him. Let's see if I can rotate him. There we go. Rotate him 90 degrees clockwise, and I'm bringing him down. So why am I bringing him down? Well, you'll see that in a second. So what I want to do is I want to take and bring one wire, my negative side there. It doesn't allow me to do that. So I'm going to have to bring a wire. I'm going to see if I can bring a wire. Let's see. I was hoping that would allow me to take a wire from there to there. All right, so let me bring this back out a little bit here. There's a XM3. Oh, that's my XMs 1, 2, and 3. That's why it's not working. Okay, never mind on that. So basically what I want to do is connect up. If I look at this guy, I want to hook up a wire. So I'm going to hook up a wire from that. I'm connect up a wire from that point, and then I'm going to bring it up to my positive rail. Boom. And then I'm going to bring my negative rail. I'm going to bring this out. Be nice if that guy just moved. Let's see what we got here. Trying to get this to move just a little bit. There we go. So what I'm going to do now is take my wire and bring them to my negative rail. Boom. So now what I did, and this is pretty sloppy, but I'm learning like you. Remember, we're all learning today. Nice snowy day outside. So winter weather has really taken a hold of us here. So that's why I'm doing this. So hopefully what you see is that I have a series circuit. So basically what I did is I've taken a wire from here to here, and my resistors are just jumping, and then I jumped another one down here. So basically the battery is right here. Everything's good to go. I'm not going to worry about the XMs. So that's fine. I'm going to get rid of that. Probably get rid of that later on, but if I wanted to connect up my XMs and all my these parts are my ohm meter and voltmeter, so don't worry about that. But if you look at it, there we go. If you look at it, I do have everything connected together. So we moved it around. Hopefully that makes sense. So you have one here, jumps to here. That one should have went right there, but I didn't, and I could probably move that wire right there. It doesn't like me. It doesn't like that. So I'll just leave them right there. Probably just connect them with another wire there, and I'm going to go right there. And I'm going to get rid of George here, delete him. There we go. Makes more sense. So wire right here. So basically I have a wire here, jumps to here, back to my negative rail. That's it. Hopefully that explains a little bit how to do a series circuit. If you have any questions, give me a holler, and that's it.